Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's algebra class. Today we are going to continue with radicals, and we're going to be talking about how to deal with operations of radical expressions. We already know how to multiply and divide and simplify. Today we're going to learn how to add and subtract radicals. And it's actually really easy. I'm going to take you back really quickly just so you can get this concept down, and then you're going to see how easy this is. If you guys remember when we were dealing with polynomials, remember how we could only add like terms? For example, 5x plus 2x is 7x, but 5x plus 2x squared, you just can't add that, right? Because they're not like terms. Remember, the like terms have the same variable raised to the same power. This lesson today is almost identical, except like radicals don't have the same variable raised to the same power. They have the same radical index and the same inside value, which is called a radicand. Okay? That's what like radicals are. Like radicals are radical expressions that have the same index. Remember, the index is this guy right here. When it's invisible, what is the index? A 2, very good. And it has to have the exact same radicand. Please remember that radicand is the value inside the radical. And only radicals that are like can be added or subtracted. Unlike radicals, such as 4 radical 3 and negative 2 radical 2, cannot be added or subtracted. So if I said on a test, 4 radical 3 minus 2 radical 2, well, that's just going to equal 4 radical 3 minus 2 radical 2. Because unless you have a calculator, you can't find that value. Or unless I start, estimating the radical 3. But you cannot add those two together because they are not like radicals. Are we clear? Okay. So let's do it. Let's practice. Simplify each radical expression. Remember, whenever we're adding or multiplying or dividing, once we have what we were looking for, you got to simplify it if possible, my friends. So 3 square root of 5x minus 2 square root of 5x. Same index, check, check. Same radicand, check, check. These are like radicals. So now just simply keep the same radical and add the coefficients, the whole numbers. So 3 square roots of 5 minus 2 square roots of 5 is simply 1 square root of 5. And I'm done. It's very similar to this. 3x minus 2x. Doesn't that equal just 1x? Same thing here. Sir, you do not need to put the 1. I'm just putting the 1 there for illustration. Thank you so much, sir. How about B, guys? Wow, quick answer. Good job. 6x squared times square root of 7 plus 4x square root of 5. You cannot add these. These are not like radicals. So, can't be added. Or you could say, not possible. You don't say no solution, guys. It's not an equation, so there would not be a solution. How about C? 12 cube root of 7xy minus 8 fifth root of 7xy. Not possible because they have different indexes. Very awesome. Way to pick up on this quickly. Nicely. Nicely done. 17 fifth root of 3x squared minus 15 fifth root of 3x squared. Excellent. 2 fifth root of 3x squared. Phenomenal. Why can I not pull out an x here? Because the index is 5. So how many x's would I need to pull one out? I need 5. I need a set of 5 of anything to pull that out. Very good. How about 5 square root of 7 plus 8 square root of 7? 13 square root of 7. Boom. Done. Awesome. How about square root of 11 minus 5 square root of 11? Negative 4 square root of 11. You are awesome. Fantastic job. Does that make sense? Pretty simple, right? Okay. Now I'm going to tweak it a little bit. Excuse me. Guys, when adding or subtracting radicals, sometimes, not always, but sometimes you have to simplify each of the given radicals, if possible, before adding or subtracting. So sometimes when you look at a problem, you may see it and say right from the beginning, hey, whoa, wait a second. Why am I even going to try this? For example, look at number A, letter A. Square root of 12 times square root of 75 times square root of 3. How are those like terms, okay? They're not. But you don't give up. You first simplify. 12 breaks up into 4 times 3, so this is 2 square root of 3. Great. Plus 75 is 25 times 3, so that's 5 square root of 3. Beautiful. Minus the square root of 3. Fantastic. Fantastic. So what's 2 square roots of 3 plus 5 square roots of 3? 7 square roots of 3 minus 1 square root of 3 is? Excellent. Done. B. Cube root of 250 plus cube root of 54 plus cube minus cube root of 16. Anybody who doesn't know what they're doing would say, oh, you can't do this. You guys know better. 250 breaks up into 25 and 10. 25 is 5 and 5. Circle the primes. 10 is 5 and 2. Thank you. Circle the primes. How many of one value do I need to pull it out? 3 in this case because of the index. 1, 2, 3. Great job, my brother. 5 square root of 2. No, 5 cube root of 2. Sorry, my bad. Got to keep that cube root. 54. That's 9 times 6. Good job. That's 3 and 3. Circle, circle. That's 3 and 2. Excellent. Circle, circle. A 3, and a 3. Very good. 3 cube root of 2. Excellent. And then minus 16. You got 2 and 8. 2 and 4. You could have done 4 and 4 if you wanted to. 2 and 2. It's going to break down to the same primes, my man. So I've got 1, 2, 3 2's and a cube root of 2 left over. Yes, sir. Yes, sir. Okay, 4 and 4 would be awesome if it was a square root. But it's a cube root, my brother. So now you're looking for sets of 3. Thank you so much for your honesty. So now, guys, can I add them now? Oh, yeah. 5 cube roots of 2 plus 3 cube roots of 2 is 8 cube roots of 2 minus 2 cube roots of 2 is 6 cube roots of 2. Very good. Okay, I got here 14 times square root of 20. That's 4 times 5. Square root of 4 is 2. 2 times 14 is 28. Square root of 5. Minus 5 times 25. And that's a 5 times 5. So take out 2 5s. That's a 5 square root of 5. 28 square roots of 5 minus 5 square roots of 5 is 23 square roots of 5. Are you guys with me here? Yep. Yes? Okay, awesome. 4th root of 32 plus 4th root of 48. This is 16 times 2. That's 4 times 4. 2 and 2. 2 and 2. So 1, 2, 3, 4 2's and 1 2 left over. So that's 2. Very good. 4th root of 2. Beautiful job. 48. 16 times 3. 4 and 4. 2 and 2. 2 and 2. 1, 2, 3, 4 2's comes out as a 2 with a 4th root of 3 left over. Can I add these? No. So you're done. They're not the same radicand. Very good, son. They have the same index, for sure, but not the same radicand. Does that make sense, my brothers? May I continue? Okay. Now, We're going to go back to what you did in the homework, but this time we're going to simplify our answer. Before, when you guys did this in the homework, you just had a long answer, but you didn't realize that you could add like terms. Now you can. So remember that you can multiply radicals of like index radicals, okay? However, you can never multiply a rational number with a radicand. What I'm saying is this. 3 times square root of 6 is 3 square root of 6. It is not the square root of 18. Now, if I go square root of 3 times square root of 6, okay, that's the square root of 18. Do you guys see the difference here? Promise? Okay, thank you guys. So, let's FOIL. 4 times 5 is 20. 4 times 4 radical 2 is 16 square root of 2. 2 square root of 2 times 5 is? No. 2 square root of 2 times 5 is? 10 square root of 2. Good. And 2 square root of 2 times 4 square root of 2 is? Okay. Close. What's 2 times 4, guys? 8. What's square root of 2 times square root of 2? 2, right, guys? So this is 20 plus 16, 36. And 16 square roots of 2 plus 10 square roots of 2 is 26 square roots of 2. I just added like terms. 8 times 2 is 16. 16 plus 20 is 36. Thank you. 3 times 5 is 15. 3 times square root of 7 is 3 square root of 7. Negative square root of 7 times 5 is negative 5 square root of 7. Beautiful. Negative square root of 7 times positive square root of 7 is? It is the negative square root of 49, but that's negative 7. Remember, when you multiply the same exact radicals, square root of AB times square root of AB equals AB. Okay? Do I have like terms here that I can add? Sure I do. What's 15 minus 7, y'all? 8. What's 3 square root of 7 minus 5 square root of 7? Negative 2 square root of 7. Done. Does that make sense? Okay. What's 3 times 2? 3 times 4 square root of 5. 12 square root of 5. Beautiful. 2 square root of 5 times 2. 4 square root of 5. Beautiful. 2 square root of 5 times 4 square root of 5. Be careful. No. 2 times 4 is? Times 5. And that's 40, right? 8 times 5? Yes, sir. Okay. It's not square root of 5 because square root of 5 times square root of 5 is 5. So, 6 plus 40 is 46 plus 16 square root of 5. You see this? Yes? Okay. For time's sake here, let me, why did this happen? Okay. Let me go ahead and scroll down. I'm going to skip that one for a second. Square root of 3 times square root of 16 will be done in 1 second. Okay, sorry about that, guys. Let's get back to it. So square root of 3 times square root of 6 is square root of 18. Then square root of 3 times 4 plus 4 square root of 3. But always I can reduce. If I can, I have, not reduce, sorry. I've always got to simplify. This is 9 times 2, so this is 3 square root of 2 plus 4 square root of 3, and I cannot add those together. They do not have, they have the same index, but they don't have the same radicand. Thank you so much. Does that make sense, guys? Okay, I'm going to skip these two just because I want to show you one last thing. Okay? And then we're done. I want to show you a little trick. Let's see what happens when you multiply conjugates and have to rationalize using conjugates. First of all, what on earth is a conjugate? A conjugate is when you have a value plus a square root, okay? The conjugate of that is literally just changing the plus for a minus. So when you have to multiply these two, someone said it already in the crowd, I love it, difference of squares. If you guys remember, if I have x plus 3 times x minus 3, if you remember, the way to multiply this quickly is the first term squared minus the second term squared. Or you could do it the long way. I'll do it the long way first, and then I'll give you the hint and show you the best way. So I have 5 minus square root of 7 times 5 plus square root of 7. Okay, we know how to do this moral. 5 times 5 is 25, plus 5 square root of 7, minus 5 square root of 7, minus 7, correct? 5 square root of 7 minus 5 square root of 7 cancel. So I've got 25 minus 7, which is 18. See how these middle two cancel? These middle two will always cancel. Why? Because of remember the product of difference of squares. If I have a plus b times a minus b, it's the first term squared minus the second term squared. So how does that help me here? Very simple. Set this up always like this, guys. Oh, wow, I got 5 minus square root of 7 and 5 plus square root of 7. Oh, it's a difference of squares. First term squared minus second term squared. What's 5 squared? Minus, what's square root of 7 squared? Square root of 7 squared, guys. What does the power of 2 do with the square root, guys? Cancels. So it's 7, which equals 18. Does that make sense, guys? Does that make sense? Okay. Next, I have 6 minus square root of 12 times 6 plus square root of 12. It's a difference of squares. So take my first term squared minus my second term squared. What's 6 squared? Minus, what's the square root of 12 squared? So that's going to equal 24. You with me? And then, last but not least, we learned this yesterday, but I just want to make sure we really understand it. Can I have a radical in the denominator? So whenever I have a radical in the denominator, I got to multiply it to the top and the bottom. So that's going to give me negative 5 square root of 10 over 10, because square root of 10 times square root of 10 is 10, which gives me negative square root of 10 over 2. And last but not least, 10 over square root of 5. Very good, my brother. Multiply square root of 5 to the numerator and denominator. It's 10 square root of 5 over 5, which equals 2 square root of 5. Homework is posted and valid. Have a wonderful day. Thank you so much. And I hope you learned a lot. Take care, guys.